The United States Navy is facing its most severe fleet readiness deficit since the end of the Cold War, driven by a domestic shipbuilding base that can no longer produce hulls at the pace required by the Indo-Pacific threat environment. Over 80% of major construction programs are behind schedule, with the Constellation-class frigate canceled after just 2 hulls, and Virginia-class submarine production lagging far below the 2-per-year target. Simultaneously, China's Navy has grown to over 370 battle force vessels, backed by a commercial shipbuilding capacity estimated at more than 200 times that of the United States. The Pentagon has requested a record $65.8 billion for shipbuilding in fiscal year 2027 and funded a $1.85 billion study to explore foreign designs and allied shipyard capacity. Navy Secretary Phelan has publicly stated that every option is on the table, signaling a fundamental shift from autarky toward international collaboration to close the hull count gap in the Pacific. The root of the crisis lies not in funding shortfalls, but in a depleted defense industrial base that has lost roughly a third of its skilled workforce since 1981 and consolidated from 13 public shipyards to just 4 active facilities. The Constellation program exemplifies the pathology. Its FREM parent design was modified so heavily that commonality dropped below 15%, adding over 500 tons of weight and delaying the lead ship by at least 3 years. High labor costs, steel prices 4 to 6 times above Asian benchmarks, and a cost-plus contracting culture that incentivizes delay have made American warships among the most expensive and slowest to build in the world. Even the emergency FFG program, based on the existing Legend-class national security cutter hull, is seen by many analysts as a modest stopgap that lacks the anti-submarine warfare capability and survivability features required for a high-end fight. Without fundamental industrial reform, simply pouring more money into the same yards will not meaningfully accelerate delivery timelines. Acquiring finished foreign warships remains politically unfeasible due to the Jones Act and related statutes that mandate U.S. naval vessels be built in American shipyards. Instead, the Pentagon is pursuing a license and build model in which allied designs are adapted to U.S. survivability standards and constructed domestically, satisfying the letter of the law while importing proven hull geometries and production engineering. The most significant industrial development is the brownfield investment strategy, exemplified by Hanwha Ocean's purchase of the Philadelphia shipyard for $100 million. Hanwha has pledged an additional $5 billion to modernize the yard, aiming to produce up to 10 vessels per year by importing Korean automation, digital twin management, and workforce training practices. This approach mirrors the Finland model used for the Arctic security cutter, where initial hulls are built overseas for speed, while later batches are constructed in U.S. yards after technology transfer, creating a legal template for future frigate programs. Among the European candidates, Spain's Navantia F-110 stands out as the lowest-risk option because it has already integrated the U.S. Aegis combat system with the Spy-7 radar at a dedicated facility in Morristown, New Jersey. The F-110 Boniface class is a 6,100-ton multi-mission frigate designed with a full digital twin that enables predictive maintenance, and its construction at the digitally tooled Ferrol yard is running ahead of schedule. The United Kingdom offers two divergent paths. The Type 26 is a superb anti-submarine warfare platform, but at roughly $1.6 billion per ship and a build time of over 5 years, it is too expensive and slow for the volume the Navy needs, whereas the Babcock-led Type 31 Inspiration class achieves a unit cost in the range of $330 to $420 million with a crew of only about 110 personnel. The Dutch Damen Sigma family brings a modular hull segment approach that allows ships to be built in dispersed locations and configured for different missions, a feature that aligns well with the Chief of Naval Operations distributed shipbuilding concept. France's FDI Belhara is the first fully digital native frigate, bearing a panoramic sensor mast and a cyber-hardened combat system, while Germany's Meko A200 remains the world's most widely exported modular frigate design, recently ordered by the German Navy itself as an emergency stopgap for its delayed F-126 program.
What sets Japan and South Korea apart is not necessarily superior warship design, but unmatched speed and scale of production, which has become the Pentagon's primary focus. Mitsubishi Heavy Industries' Mogami-class frigate, which operates with a core crew of just 90 sailors thanks to extreme automation, is built at a rate of approximately 1 hull per year, and its upgraded variant with 32 vertical launch cells won Australia's $10 billion general-purpose frigate competition. South Korea's Hanwha Ocean builds the FFX Batch 3 and Batch 4 frigates with a tempo of around 2 years per hull, and its Jiaj yard possesses massive covered dry docks and heavy-lift cranes that dwarf American facilities. Hanwha's Philadelphia acquisition directly injects this tempo into the U.S. industrial base, and its partnership with the naval design house Leidos Gibbs & Cox is adapting Korean designs to meet full U.S. Navy specifications. Meanwhile, Japan has recently passed legislative changes to facilitate defense exports, and the Merchant Marine Allies Partnership Act, introduced in Congress, would create a foreign ally shipping registry, further lowering political barriers for Japanese and Korean participation in the U.S. shipbuilding enterprise.
A comparative analysis of the leading designs reveals clear groupings based on cost, build time, crew size, and combat system alignment. The Navantia F-110 is priced at approximately 860 million euros per unit, with a build span of around 5 years and a crew of about 150. Its primary advantage is the seamless integration of the Aegis combat system. The Babcock Type 31 is the most affordable Western frigate at roughly $420 million, requires only about 110 crew, and can be built in 4 to 5 years, though it lacks the high-end anti-air warfare capability of Aegis-equipped platforms. The Mitsubishi Mogami comes in near $400 million, with an industry-leading 3-year construction cycle and a crew of just 90, making it the most personnel-efficient option. Damon's Sigma variants span a wide cost band from $400 to $600 million, with build times around 4 years and crews around 110. Their modularity offers the greatest mission configuration flexibility. At the higher end, the French FDI and German MEKO A200 both approach or exceed the $1 billion threshold, putting them in direct competition with existing U.S. destroyer costs, despite their advanced features.
Any foreign design adoption must be evaluated against realistic production models rather than theoretical maximum rates. Under a baseline scenario, using only existing U.S. yards, the Navy can realistically produce 1 to 2 frigates per year, reaching perhaps 15 new hulls by 2035. An accelerated scenario that pairs a licensed design like the F-110 with a revitalized brownfield yard such as Hanwha, Philadelphia, could achieve 4 hulls per year by the early 2030s and deliver over 30 frigates by 2035, provided the workforce and supply chains are in place. A constrained scenario reflecting persistent shortages of skilled welders and engineers, currently estimated at a deficit of 250,000 workers across the defense industrial base, would limit output to a single frigate per year and render the Navy's 381-ship target unattainable. The Hanwha model is especially instructive because it includes a deliberate strategy of importing experienced Korean trainers who are teaching robotic welding and digital construction management to American workers, directly attacking the skills gap that has crippled domestic production. The evidence from April 2026 indicates that the most logical approach is a 2-track strategy that leverages European design maturity and Asian manufacturing speed within a legally compliant American build framework. The immediate priority should be to license the Navantia F-110 design for construction in the United States, using its proven Aegis integration to minimize combat system risk, while delivering a true multi-mission frigate to the fleet by the 2029 target. In parallel, the Pentagon should execute a fast-track acquisition of either the upgraded Mogami design or the Hanwha FFX-4 through the Philadelphia yard, taking advantage of 3-year build cycles and lean crewing to rapidly boost hull numbers in the Western Pacific. This dual path respects the Jones Act, creates thousands of American shipbuilding jobs, and offers the only plausible chance of closing the gap with China's accelerating naval expansion before the end of this decade. Without such bold industrial integration, the United States risks ceding maritime dominance in the Indo-Pacific to a competitor that already outproduces it by a factor of 200 to 1.